Hi, in this video, I'm going to show you how to perform this Mann-Whitney U test. It's also called Mann-Whitney-Wilcoxon test. It's used when you want to compare two samples, but the data does not follow normal distribution. So this is non-parametric test. It's an alternative of t-test. Basically, t-test is parametric, where there is a strict assumption of normality, but many times this assumption is validated, and there you can use non-parametric tests. And one of the non-parametric tests that is often used to compare samples is Mann-Whitney U test, or it's called Mann-Whitney Wilcoxon test. So we'll take a data set uh, to do this, to perform this test. So we have this data set empty cards. Okay. Before that, the null hypothesis here is that the distribution of the two samples we have taken for comparison is same. That's a null hypothesis. The alternative hypothesis is that the distribution is not the same. It's not equal. But we are precisely interested in comparing the mean. So null hypothesis is that the means between two samples, given samples, is same. The alternative hypothesis is that the means are different. So either means are same or means are different. So that's what we like to prove here. So that's the hypothesis with us. And we'll take a data set. Okay, empty cars is something that we've taken in other videos. So empty cars has a lot of fields related to automobiles. We're interested in mileage, and we have two transmission types. Okay, that's captured in the field AM. So there are two transmission type, or automatic and manual. So it's denoted by 1 and 0 basically. So we like to compare these two samples where uh, the transmission type is automatic to the transmission type manual, right? So that's the variable of interest is mileage, but we like to know with respect to trans uh, transmission type, which takes a value of 1 and 0. All right. And okay, let me also just show you what is transmission type. Okay, so that's cards. Okay, so you have just got 1 and 0 basically. Okay, there are two categories in that particular field. So let us, so in order to run the Mann-Whitney U test, we need to use this command wilcox.test. And the syntax is more like syntax of linear regression. So provide the variable of interest in the left hand side, and with this tilde, and then afterwards the variable that is used for the segmentation. So transmission type basically here. Okay, so mileage with respect to the two transmission type, and then obviously you'll have to provide the data set where you have these fields. So let us run this. Okay, so there is some warning message, but that's fine. We have got the values, right? So here it says that, okay, the p-value is 0.01871. So in hypothesis testing, if the p-value is less than 0.05, then we reject the null hypothesis. And that's at 95% confidence level. You can also have 99%, 90%, but the most popular one is the 95% confidence level, where the p-value is 5%, whether it's 5% or less than 5% or more than 5%. That's something we are interested in. And here we see that p-value is 0.001871, therefore it's less than 5%. And hence we reject the null hypothesis. And the null hypothesis was that the distribution of these two categories, the two samples, transmission type automatic, transmission type manual, are equal, but that's rejected. So the conclusion is that distribution is different in these two samples. When we're interested in the mean, so the mean is actually not equal, it's rather unequal. So that's the conclusion. And remember one thing, this is something useful only when the data that you have is not normally distributed. If it is normally distributed, it's better to go with the um, t-test, right? Not with this non-parametric test, because non-parametric tests are um, I mean, they're secondary in nature, as in, if the assumptions are met, it's better to go with parametric test because it's theoretically more sound. But non-parametric tests are theoretically, less sound and bit difficult to interpret also sometimes.